Good evening, everyone. My name is Yash and I am from Acropolis Institute of Technology and Research, and my topic is Hive in Big Data. So, first of all, Hive. Hive is a powerful data warehousing tool within the Hadoop ecosystem. Hadoop Apache Hive is a data warehouse framework built on the top of Hadoop that allows you to analyze large data set stored in HDFS. HDFS means Hadoop Distributed File System using a SQL like a language called Hive SQL. It offers a SQL-like interface allowing users to efficiently manage large datasets stored in Hadoop HDFS. This makes it essential component for data analysis and engineers who work with big data. Thank you. And next slide is introduction to Hive. Hive, what is Hive? Hive is a data warehousing solution built on top of Hadoop, facilitating large dataset management using Hive HQL. Hive HQL, purpose of Hive. The purpose of Hive is to simplify data summarization and analyze through SQL queries, making it accessible for non-programmers. Key feature and now key features like schema evolution and partition tables enhance query performance and flexibility for managing large data set. Architecture overview. Hive architecture has four major components. Provide interfaces like Web UI, JDBC, ODBC. Users submit queries through these interfaces. Next is driver. Manages the life cycle of a Hive SQL statement, includes the compiler, optimizer, and executor. And next slide is Hive architecture. It contains of three portion meta store, schemas and partitions. It stores metadata about Hive tables, schemas and partitions. Metastore. Metastore is a central repository storing metadata about databases, tables, partitions, columns, data types and location. Usually uses RDBMS. RDBMS such as MySQL, Derby, etc. to store metadata. Next is execution engine. Execution engine is coordinates the execution of tasks generated by the driver. Executes on Hadoop or Spark clusters. Next slide is challenges and limitations of Hive. Challenges. Hive presents several challenges and limitations that may affect its effectiveness in various applications. These issues relate to latency, optimization of complex queries, and limited transaction support, emphasizing the need for careful consideration in selecting Hive for data processing tasks. So first of all is latency. High latency for query compared to real system, unsuitable for time-sensitive application. Next is complex queries. Complex query is challenging to optimize, requiring in-depth understanding and tuning for better performance. And next is limited transaction support. So what is limited transaction support? Transaction support inadequate transaction supports compared traditional RDBMS impacting asset compliance application. Compliance means atomicity, complexity, and then again next slide is advantage of using Hive. Hive. So then three points are there: easy of use, scalability, integration, and other than this, like SQL, like querying, handles big data, extensibility, schema on read, integration, cost effective, supports various file formats, partitioning and bucketing, batch processing, security. So first of all, easy of use. High SQL like language makes it easier for users familiar with traditional databases to transition and leverage big data technology without extensive programming knowledge. Second is scalability. Built on Hadoop, Hive inherits scalability features, allowing it to handle petabytes of data by adding more nodes to the cluster seamlessly. Third is integration. Hive integrity well with other Hadoop ecosystem tools like MapReduce, HBase, Peak, creating a robust performer for comprehensive big data management analysis and cost effective. It is open source and Hadoop based. Built on Hadoop ecosystem uses commodity hardware. Support various file formats, supports text, ORC, Parquet, Avro, RC file, JSON, etc. And third is schema on read. Hive doesn't require schema when data is stored. It applies schema when reading data. Fourth one is user-defined function, which means extensibility. We can write custom functions in Java, Python, etc. And next it handles big data, works on top of HDFS processing petabytes of data. It is one of the most important advantage of using Hive. Next slide, performance optimization technology. It has three parts: partitioning, bucketing, and indexing. Partitioning means divide data based on specific column values, improve query performance. In this data is divided into in different columns, and and this helps in query performance. And second one is bucketing. Bucketing means organizes data into similar manageable files, enhancing performance during joins. When we use joins, it enhances the performance of data, and it is very important part of the data retrieval. Third is indexing. Indexing means creates indexes on frequently queried column for faster data or retrieval. Next slide is data storage and next is data storage and format. Data storage means Hive itself doesn't store data. It manages and organizes data in HDFS. HDFS is Hadoop distributed file system or other computable storage like S3, HBase, etc. In this is format, tables and partitions are there, file formats are there, optimizing storage are there. Key concept schema on road. I follows schema on road instead of schema on write. Data is stored as in HDFS. The schema is applied only when you query the data. This means we can load semi-structured or even unstructured data into Hive tables. Hive data storage structure. First of all, database. Each database in Hive corresponds to a directory under Hive warehouse directory. Next is tables. Each table is stored as a subdirectory inside the database directory. Third is partitioning. Each partition creates a subdirectory for each partition key value. Example, if a data table is partitioned by year, month. The fourth one is buckets. Buckets, which is optional within the partition data, can be divided into buckets, which will file based on hash function. Third is Hive table, in Hive table it manages data table internally and external table. Next slide is overview of Hive Hive QL language. HiveQL is a powerful query language that allows users familiar with SQL to manage and manipulate data in Hive effectively. It supports data definition and manipulation through various methods. First is HiveQL basics. HiveQL is a SQL-like language for data interaction. Second is data definition language. It means command for creating and managing table. Third is data manipulation language. HiveQL is similar to SQL but designed to work on large datasets stored in HDFS. It allows you to define, manage, and query data easily. Hive commands are broadly divided into three categories: DDL, DML, and other than the DDL command in Hive define and manage database tables, partitions, and views. It creates database and create with a specific HDFS location. Second, and in this drop database, which means deletes a database. Third is create a table in Hive. Fourth one is partition table, external table, bucket table, database, alter table, drop table, and next point is data manipulation language. In this, load data from local or HDFS file into a table, insert into tables, insert queries into table, create tables as select, create and load a new table from a query, export and export Hive table data and metadata, delete, delete and update, high support update and delete on acid enabled transitional tables, decalculate data query language in which it is used to query or retrieve data using select, group by, joins, aggregation, subqueries, limit, high QL workflow. DDL means create, alter, drop, show, describe. DML means load, insert, export, update, delete. DQL means select, join, group by. Last is conclusion. On Hive role in big data. Hive is a vital tool in the big data landscape, simplifying the complexity of query Hadoop data with an SQL-like interface. While it has limitations, its advantage make it suitable for data warehousing and analysis in massive datasets. Users can leverage Hive to deliver valuable insights and knowledge from their data, deriving informed decision making. High significance, easy of use, advantages, and application driving insights. Thank you.